Welcome to our online stats video. First thing that we're going to do here is go through the last little bit of chapter 9, which we didn't finish covering before SAIT got closed. The part that we're going to be looking at is confidence intervals for population proportion. We already looked at confidence intervals for other situations, specifically for the mean when we knew sigma and the mean when we did not know sigma. So this is just going to be a variation on what we already looked at. So where we need this is when we're looking for a percentage or proportion that fit into a particular category, whatever that is. So this is a lot like our binomial distribution. Remember, with the binomial distribution, we had two categories. It either fits into the category, it doesn't fit into the category. So same thing here, we're looking at stuff that fits into a category or not, so we're using P and Q. And we've got this little P hat as opposed to just the regular P. Remember, that means that's our estimated value when we put the little circumflex above the P and the Q. Also remember that Q is just 1 minus P. So same steps as we have for creating a confidence interval, but now we have a little bit different formulas. So a quick recollection, what are those steps? I'm going to pause to let you think about it. And if you want to take a moment to pause the video and write them down if you think you know them, that would be good too. So first step in any sort of question is going to be figure out what kind of question it is, right? So we want to look at what sort of confidence interval it is. Is it going to be a means confidence interval or a proportions confidence interval? I didn't go quite far enough there. Second step is figure out what do we know. Right? And don't forget to figure out what the variables are that go with those things that we know. Third step, figure out the z-score that corresponds to our confidence level. And remember that confidence level is our certainty of being correct. How certain do we need to be? And then we can calculate the margin of error. So we looked at the formulas for the mean last day. Our formula for margin of error for the proportion is right here, where we've got E equals Z times the square root of P hat Q hat over N. Once we've got that margin of error, we add and subtract the margin of error from our point estimate to determine our upper and lower values of our confidence interval. And last step, but not least, don't forget to write yourself a statement that clearly indicates what we're talking about. So we're going to look at the first example of this section. So when 500 students are randomly selected and surveyed, 395 had debts of 10,000 or more. Determine the 95% margin of error and corresponding confidence interval estimate. So again, with these questions, it's nice in there. It really says very clearly we're looking at a confidence interval. Right? Tells us really clearly in the question. So once we have that confidence interval, once we know that we're looking for a confidence interval, then we're looking for which kind of confidence interval. So in this case, it's not really obvious in this question. There's nothing that says, oh, use a proportion confidence interval, or use a means confidence interval, or a confidence interval for the proportion or mean. So you kind of have to read this one carefully. Now we see that it's saying so many out of a total. So it's kind of subtle. You got to watch for these ones because sometimes they are a little bit subtle. So if we're looking at a certain number out of a total, that's telling us proportion, right? It's a fraction. So fraction is another way of saying proportion. So our type of confidence interval, we know now this is a proportion confidence interval. So the n that we've got in this question, right, our total number of students, 500. And our x is going to be the numbers that fit into our category, in this case, unfortunately, having debt. And our alpha, remember, comes from our margin of error. So it isn't our margin of error. Remember, it's 1 minus our margin of error. So if our margin of error is 95, our alpha is 5% or 0.05. Now what good does that do us? Remember, that tells us what our mean what our Z score should be, right? Because we know that alpha is the shaded regions on the edges. It's our chance of being wrong. So in this case, we split that in two, always for confidence intervals. Remember, split that in two. And so we have to look up that 0.025, and we look it up on our data table. So on our data table, we're looking for 0.025. Remember, we're looking for the area, so in the middle, and we want to find 0.025 or as close to it. A common mistake that people make is sticking in an extra 0. So it's not that 0.0025, it is just 0.25. So it's going to be this one right here. So be careful that you have the decimal in the right spot, right? Also not just 0.25, somewhere down here. It's going to be 0.025. So remember, we go across and we see the corresponding value, negative 1.9 on the side there, and up here to 0.06. So remember, when we write that value for Z, we have the plus and the minus on these questions. It doesn't matter which one we write down. Eventually we're going to add and subtract it anyways, so that will work. So we go back to our question, and we have that Z is 1.96. For the formula, we usually use the positive, just makes things simpler. So since this is proportions, we're putting that into that proportions formula. So our Z is 1.96. Where am I getting this P hat and Q hat from? If you hadn't figured it out already, remember P hat is X over N, so we go 395 divided by 500. That's where the 0.79 comes from. The Q, remember, is always 1 minus P, so 1 minus 0.79 gives us 0.21. And again, our N is 500. So we do that calculation, and again, if you need to pause so that you can do the calculation, this would be a good spot to do it, and continue the video once you've got your answer. Calculation does work out to 0.0357, which, remember, this is proportion, so we're looking at percentages, so we can change that decimal. It's okay if we still want to work with the decimal rather than the percentage. Usually, though, on these we answer in percentages in the final answer. So once we have that value, remember, our next step is to add and subtract to find our upper and lower values. So our P hat, still the 0.79 that we got from going 395 divided by 500. And our E, the value we just calculated, so 3.57%. So we need to subtract that from our point estimate, and we need to add that to our point estimate. First, the subtraction will give us our lower limit. The addition will give us our upper limit. Again, pause the video if you want to do the calculation before we move on. Right, the lower limit ends up being 75.4%, the upper limit 82.6%. Don't forget that statement. So this particular question asked us for both the margin of error and the confidence level. So margin of error is 3.6%. The confidence level is between 75.4% and 82.6%. Now, I did specifically say what the proportion was of. A little wordier this time than sometimes. The with 95% confidence, not absolutely necessary to have it in your statement, but it is kind of nice to know what that confidence level is. Okay, moving on to the next one. If you're feeling comfortable, I encourage you to try this question before you continue the video and have the answer for you. However, if you are wanting to just go through and see what that's going to be, keep watching without pausing. So again, we want to look for what tells us what kind of question this is. Well, we have to find the interval estimate. So again, that big word interval there. This time it's a little more obvious. Find the proportion of the whole population. So it's not quite as tricky as the previous question in terms of the wording. Again, we've got to find those values. So our N, 1068, our X, 673. We can use those to find our P hat, 673 divided by 1068. Works out to 0.63. Q hat, remember, is always 1 minus P, so 1 minus 0.63 works out to 0.37. Alpha in this case is 0.01. So if we find that on our chart, we're not looking for 0.01 itself. Remember, we always divide it by 2, so 0.005 on our chart. This is one of those starred values. So if we look at that starred value on our chart, we can see it comes down, and it's equivalent to minus 2.576. And I think I actually typed this one in as 2.575 because I went exactly halfway in between. Let's see what I did in the question. I did use 2.575 because I went in between. I was looking at an older edition of the formula sheet when I typed in these values. So my answer is going to be slightly different if you use 2.576, but that's going to be pretty close. By the time we round it, we'll probably be almost the exact same number. I, again, would give a little bit of wiggle room on that one. Intro math being marked by a computer doesn't give you quite as much wiggle room, but certainly for tests, which I look over and mark myself, you've got that little bit of wiggle room when you have those in-between values. So we plug that in for our z-score, got our p-hat and our q-hat, which remember we can also write q as 1 minus p, and our n, and we end up this time with a margin of error of 3.8%. So we're going to take that and we're going to add and subtract it to our 63%. That was our point estimate. When we do, we get our lower limit, 59.2%, upper limit, 66.8%. Don't forget to include that final statement. So between 59.2% and 66.8%, have an answering machine or service with 99% confidence. I'm thinking that number's probably gone up since that question got made. Selecting the sample size to estimate the proportion. So just like with the means, we can rearrange that formula for the margin of error and make it be our formula for n. So when we rearrange that formula for n, we get n equals p hat q hat times z over e all squared. But we have a little bit of an issue on that one, because if we are using this to figure out how big do we need our sample to be, and we don't have a clue about p hat q hat, because that's what the whole test is about, what are we going to do to put in for these numbers? So just like with our calculating n when we were doing a means confidence interval, we may need to get that estimate from somewhere else, right? So that p hat and q hat we might get from a smaller study, we might get from previous data at a different time and say we think it's still going to be close. But sometimes we really have nothing to go on. So then, if it's completely unknown, we use the largest possible product for p hat q hat. Now when I'm going through this with a live class, I usually say, what's that largest possible product going to be? And often someone thinks it's going to be 1, because p, the largest value, is 1, right? Because remember, it's percentage. And we can't get more than 100%. But when p is 1, q is 0. So p times q works out to be 0. If we move a little ways off of that, right, if p is 0.9, then q is going to be 0.1, p times q is 0.09. And as we keep going down this list here, you can see it's slowly getting bigger and bigger, and it gets its biggest when p is 0.5 and q is 0.5. And then it starts to go down again. So I didn't continue on with that chart because we can see, well, it's just going to be exactly the opposite. It's going to go to 0.21, 0.16. And this works whether we're using 1 decimal or a lot more. So we can see our largest possible p and q, when we multiply them together, is going to be 0.025. So our n formula becomes 0.025. With that value, you do need to know that for the situations where you're not given p and q, because the only formula you have on your formula sheet is the version that's n equals p hat q hat brackets z over e all squared. So if you don't have p and q, you need to know to substitute the 0.25. So just like with estimating our sample means, this is going to give us a minimum value, so calculate n, always round up, even if you get like 0.03. You got to round it up to the next whole number, because we can't have half a thing in our sample. Okay, so looking at our next question. Keywords here. Well, again, just like when we're estimating sample means, something in the question is going to be asking us how many, right? It might say what number of, how large should the sample be, but somehow it's asking us how many. So we know we're looking for n. So if we have n, we're going to need to have confidence level and a margin of error. So we've got 95% confidence. Remember, that tells us our alpha. And our alpha indirectly is going to tell us our z-score. So this one again is 95%, so like an earlier example we had with 95%, we end up with a z-score of 1.96. And this question is pretty clear. We've got 3% error. So 3% error is telling us our E. Lots of times that E is a lot less obvious. I mentioned to you when we were doing the sample means n that margin of error often is just a simple word within. So when it asks you, you want to be within 3%. That is the same thing as saying 3% margin of error. So in this first part of the question, it says we have no prior information. So that's our scenario where we're going to replace our 0.25 for the p hat q hat. So we've got z, we've got our margin of error, we can plug those in. Remember, on these questions, common mistakes are not squaring things that need to be squared. And a big hint that you may have missed something in your calculation is if you end up with a small n. Remember, we expect these to be at least 30. If we get less than 30, you want to seriously question your calculation. There's a chance you could end up with less than 30, but the vast majority of the time on these questions, you're going to end up with an answer over 30. So again, pause the video if you want to do the calculation. But the answer is 1067.11. Remember that 0.11 we've got to round up to the next whole number, so when we write our statement, we're going to say we need to survey at least 1,068 students if we want this information to that level of error. So that was the first possibility. We had no prior information, but maybe we had some information. So part B is saying a previous study shows the percentage to be 30%. We have reason to believe it hasn't changed significantly. So that 30% is telling us, oh, go ahead and use 0.3 for your p hat. So in that case, we would use this version of the formula with the p and the q present, and we would put our 0.3 for our p, and our q is 0.7. The z and the e are the same as the first part of the question, right, because it's the same scenario. So we plug that one in and we get 896.37. Again, got to round it up to 897. Okay, next question. Again, I encourage you to pause the video and try doing the question on your own. So first step, identify what kind of question this is. So what are we being asked for? Determine the sample size. Second step, let's look at what we know. So 95% confidence is telling us that alpha is 0.01. So from that we can figure out our z. And this one, we've got the error will not exceed 0.02, right? So within 2% error. And note with these margin of error for proportions, that's always got to be written as a decimal. So back here on the previous question, I'm actually going to scroll back. where we had 3% margin of error, we changed it to 0.03. Here it's already as a decimal, right? There's no percentage there, so we leave it as 0.02. We do have a p hat, 20%. So that alpha indirectly tells us our z-score, 0.005. We look up, and again we see that z-score 2.575 or 2.576, depending on which version of the table you're looking at. And so we get 0.2 times 0.8 over 2.575 over 0.02 squared. And I'm going to double check that calculation because I wrote things a little bit oddly. Do get that correct final answer, but I'm not sure why I have 51.5 squared. That's the part that seems a little bit weird. So I'm just going to take out that step. So again, round that up, at least 2,653 people need to be included in the sample. One more example question here. Again, pause if you want to work on it yourself. Hopefully by this time you've got a good grip on this kind of question. So start out, 92% confidence. Actually, what kind of question? How many students? Tells us we're looking for n. Alpha, we know 92%. Alpha is going to be 0.08. So from that we can look up our z. That's a new z we haven't used, so let's take a look. Whoops, that is not what I wanted to click on. So 0.04. So our closest value to 0.04 right here. So 1.7, can't see the top of my screen, 1.75. Margin of error, there's that within, right? So watch out for that. Within tells us our margin of error. 0.05. So we're looking for n, got all our values, plug them in, get our calculation done, 306.25, round up to 307. And so there's the last two little topics in the chapter, finding our confidence interval for proportions and finding our sample size if we want to estimate proportions.